Hello. Huh? Amber. Hey, hello everyone. Are you able to hear me? And are you all able to see my screen? I would do a quick poll question and I request every one of you to respond. Are you all able to see the screen? Yes or a no? Here is a poll question coming your way. Can you all please respond to this? Wonderful. Thank you so much for responding. 100% of y'all are able to see the screen. And I will put another poll question here. And that poll question is, are you all able to hear me? Yes or a no? Please, can you all respond to this? Yeah. Please, can you respond? Wonderful. A lot of y'all are able to hear me. So I think we should get started. Even before we get started, let me quickly write two things, couple of things on the screen. Number one, is if you are not able to hear me, then please check your audio settings. Okay. If you are not able to see the screen, then reconnect or rejoin. Okay. So that you do not face the issues. Because I think 4% of you all are saying you're not able to hear or see my screen. So please check your audio settings, and if that does not fix the issue, please reconnect or rejoin and you should be able to see the details. Now, let me quickly share my profile. This is me, my dear friends, and I am today representing 360DigiTMG. Digit stands for digital transformation, M stands for management, and G stands for governance. I happen to be Industrial Revolution 4.0 implementer, chief data scientist, and technology advisor on 4 different firms. I hold master's degree in technology and I have an MBA degree. I worked in the past with HSBC, Indian Tobacco Corporation, Infosys, and Deloitte as an employee, post which we formed a company called as Innodatatics, which is a USA-based analytics consulting firm. I work as a director on that firm. And please focus on the session, friends. What am I using to write and all that we shall discuss later. I'm a chief data scientist on Broadband Analytics, Athena Technologies, and I happen to be director of 360DigiTMG as well. So let me also show you a few posts and activities that I've done here. And we have accreditation from IBM, and people get IBM certificate like this issued by 360DigiTMG. And this certificate, the moment you post, carries its own sweet value. But nevertheless, let me get to the post. We have this tendency of giving it back to the society. So every month, we conduct one free session for 2 hours or 4 hours on the emerging technologies, on the emerging trends. If you want to be notified of the emerging trends and technologies, all you need to do is, I'm going to share a screen with you. Okay. Take the screen, take this link, and you might want to click on that And all you need to do is, oh, is there an echo? If there is an echo, then people from our side who have joined have to mute themselves. Lavanya, if you're there, I request you to mute yourself. Is there an echo, friends? Let me ask that also as a question quickly. Is there an echo? Yes or a no? Okay. Please, can you respond? No. Okay. Good. So if there is no echo, then that's fine. Absolutely, we should proceed further. So that's the link that I've shared. You just need to follow our page so that anytime we conduct these kind of sessions, you're notified. So you need to just follow the page. So 5th and 6th, last month, we conducted a session on machine learning on cloud, which included AWS, Microsoft, Azure, etc. You might want to do that. Okay. Using artificial intelligence and data science, you can also build robots. And this is one such robot that we have built. And this robot will raise the hands, it will walk, right? So on and so forth. Okay, and you have something here. It's going to track your attendance automatically. It will talk with you, so on and so forth. It will give you a shake hand and all that. Do you know what? This robot is an AI-driven robot which was built by data scientists from Innodatatics and our participants who got trained through us through 360. So we believe that practical applications, if you do not implement, then it doesn't help. Okay, so you need to practically implement the solutions. After learning your data science and AI, only then you will be able to remember things. There is a B school called as Indian School of Business, which is globally ranked in top 20, right? It's Financial Times top 20 B schools, from where I also graduated. And I keep conducting trainings for ISB as well. We have written a book which is called as Enough of Theory and Become a Practical Data Scientist within 100 days. And what I will do is, this book was written by 3 people and I am one of the core members who have written the book. Let me go to 360DigiTMG, and here there is an option called as Learning Resources. When you click on Learning Resources, you just need to scroll down and you would see a book called as Digital Book. And you can just access. Okay, I'll just move this. The book that we have written has 600 plus pages, but we are giving 168 pages worth of book for free. Okay, we believe that humans learn through images. So we have put a lot of images and less of text. Okay, that is what we have done. I will share this link with you all, and please bookmark this link. And yes, this session is being recorded. Okay, all right, so let's move on. So please bookmark that and you can actually read the book at your own leisure. Next, we also at this point of time should understand that data science or artificial intelligence, data science or AI is industry agnostic. What do you mean by that? It is industry agnostic, meaning it is not applicable to only a specific industry or sector or domain. Data science or AI is something which is applicable to all the industries, sectors, and domains. Just give me a bit. Did I connect to a wrong one? No, it's the right internet connection. Okay. So this is manufacturing and automotive analytics. People who are from manufacturing background, or people who are from automotive background, or people who are from mechanical background, they are the kind of people who are also eligible to become data scientists or AI experts. Okay. Do not assume that data science or AI is a profession confined only to computer science or information technology professionals. No, it is applicable to all the industries. And we at 360DigiTMG have 56 plus domain analytics trainings, construction analytics, retail analytics, financial analytics, and a bunch of those. And we have a book like this. And we have accreditation with UTM, of course. And do you know what? On YouTube, we keep posting a lot of interesting videos. Let me speak about a few of these. And when you go to 360DigiTMG, when you scroll down, you have a social media forums in which you have LinkedIn. At this point of time, I want to speak about 4 things which will benefit you all. Number 1, on weekly basis, we conduct 4 very interesting sessions, free of cost. Number 1, there is going to be an interactive session every Wednesday from 7 p.m. or that would be 9:30 p.m. to 10:30 p.m. Malaysia time. Okay, and you'll have sessions on info basically. So the industry leaders from various companies, they come join. You can ask them questions on how is technology going to be, what kind of things would come up in the future. You can ask those kind of questions. Second, people who got trained through us, majority of them eventually get jobs as data scientists. When they get a job, what we do is, and I mean this happens weekly basis, once in a week, we conduct something called as success story sessions. What happens in success story sessions is that people who are from non-IT background or people who are from IT background, people who have 0 years of experience in data science, that is freshers, or people who are working professionals who are already working in various companies, in various capacities. These people conduct a session for an hour to help people understand on how they have transitioned their careers into becoming data scientists. Okay, from the time they joined our training until they become data scientists, how did they traverse the journey? Weekly, one person will come and deliver the session. So there are, in the last 1 year, there are 138 people who got jobs. And everyone comes and explains about their learnings. Third, we also have something called as project presentation session. What is this project presentation session? People who join trainings to us, they also basically do live projects like the robot that I've shown you, right? That's one of the practical projects which our students have done. So they come and do project presentation. How is it going to help you? If you attend these sessions, you will understand on how to do projects end to end using data science concepts. And vis-a-vis, how do you prepare your resume, right? How do you prepare for your interviews? How do you get a job, right? All those topics will be touched upon. And this would be on every Sunday. Every Sunday this would happen at 9:30 p.m. to, it will go on until 11:30 p.m. Malaysia time. Okay, and finally, there is also interview preparation session which happens. This interview preparation session happens every Saturday from, again, 9:30 p.m. Malaysia time to 10:30 p.m. Malaysia time. So every Saturday, Sunday, Wednesday, you have umpteen number of sessions which happen. I would strongly recommend you all to just subscribe and click on notify so that you are notified about all these things. And these things are extremely beneficial for students and even the professors basically, because a lot of professors also join our sessions. And this is the link which I've given. I've just posted on the chat window. You might want to just click on that and do those two things. Okay, just click on subscribe and notify. You would be notified 100% whenever we have such sessions. Next, we have built an AI-driven attendance tracking system. This is a product that we have built as part of COVID-19. So what would happen now is, if you start using biometric system to track your attendance, you stand a risk of spreading virus, COVID-19. Hence, we have come up with automatic face recognition system, wherein it will scan and quickly give the attendance. Not just that, we also have thermal sensors. These thermal sensors will track the body temperature. Okay, and it is going to capture the body temperature as well. And this report goes to the reporting managers saying that, hey, your employee has logged in at this time, logged out at this time, a bunch of these. And this is a product which will very soon be installing. We already installed it in Coca-Cola, not just our office, in Coca-Cola as well. We're going to install a similar kind of setup in our Malaysia office also for your demonstration. You can come experience that. And this is a product which was also jointly developed by Innodatatics alongside our team of participants who got trained to us. And 360DigiTMG is the only edtech company to have partnered with Panasonic. Panasonic is a company which is 100 years old, and they have their innovation centers in Japan, in USA, and in India. And Panasonic works in the space of healthcare. Friends, this is very important. Very, very important. The things that I'm telling you, this is going to set the high level context on what is data science, what are the applications, etc. So please focus. Manufacturing, automotive, and home appliances. We all assume that Panasonic works only in the space of home appliances. That's wrong. It's a Japanese conglomerate. Let me give you an example of aircon. What happens is, a lot of components might fail pertaining to aircon. So people from innovation team of Panasonic, they have placed industrial IoT sensors on the aircon, and they started getting the data. And they placed the data on cloud. Once they place the data on the cloud, they they do predictions using machine learning algorithms. And the predictions will predict on which component of this aircon will fail and when will it fail. This information is shared with the technicians, and technicians will proactively go and fix this issue. This is called as preventive maintenance using predictive analytics, predictive modeling. These are the kind of use cases which are introduced as part of our 360DigiTMG training curriculum as well. There are a lot of other projects which I'm going to speak. We also have partnered with City and Guilds UK, which is UK's #1 accreditation body, IBM, Panasonic, bunch of those. Yeah, this is an interesting. We also built a project in the space of COVID-19. So we forecasted the number of COVID-19 cases. We have done this 6 months back, 7 months back. And when we have built this model on how many COVID-19 cases will we have in India for the next 1 month, we could forecast with an accuracy of 98%. 98% accuracy. It is one of its kind. And then this project was taken forward. South Korean scientists have taken it forward. In India, we were asked not to do anything pertaining to COVID-19. Hence, this wasn't taken forward, but we have achieved an amazing accuracy. We also do projects for government of India here. And this is one such project wherein if you just place a box like that, and the moment a vehicle passes through that, it's going to automatically track. Do you see that small bounding box? Yeah, pink color. Then pink color. This is in some green or blue color. That way. So all the vehicles passing through are getting recorded. This information, if you share with Roads and Buildings Ministry, then they will probably, if the traffic is increasing at a rapid pace in this region, they will expand the road. Or maybe they will have some kind of a traffic signal to regulate the traffic. And this information gets saved in the backend database like this. So you need not manually count. Automatically, you know on how many vehicles cross that specific region. We have also built an AI-driven chatbot for food, giant here in India. All you need to do is scan the QR code, which would pop up a window, and you can place order for the food while you're placed on the table. Okay, while you're placed on the table, you can. So this is yet another application. And this is a project done by our participants from Malaysia. Okay. And I think 3 or 4 students, along with our own team of data scientists, have done this project. Amazing job, right? So in a video, it would place a bounding box around the face, recognize your gender and your behavior on whether you're happy or sad, or are you neutral, bunch of these things. Okay. And these are amazing applications. Let me also show you Innodatatics. Friends, we were ranked as 20 most promising data analytics solution providers for 2018 by CIO Review USA, United States of America. And we operate in the space of all these industries. We operate in the space of automotive. To explain about how we have done that project, let me quickly go through this. If you just type PMI Survival Analytics, the first link that you see, you just need to click on that. And you see that name? That's my name, Bharani Kumar. And in this particular project that we have done, we have very clearly listed down on what project management methodology did we implement, what was the technical roadmap, and what was the high-level architecture. Okay. So if a vehicle moves from one point to another, okay, if a vehicle moves from one point to another, for example, say you're transporting goods from KL to Johor. If the vehicle breaks down midway, say your vehicle broke down here, then a lot of stakeholders are negatively impacted. Who are those stakeholders who are negatively impacted? Receiver? Or let me ask this question. Tell me, friends, who are the various people who might be negatively impacted? Can you please keep posting these things on the chat window? Please can you post on the chat window, friends? Come on. I request everyone to be proactive in terms of responding. Feel free to respond. Who are the various people who might be right? Absolutely, Justin. Wholesalers, yes. And who else would be negatively impacted if a vehicle breaks down in a specific journey? Come on. Let me see. Wonderful. Passengers in the vehicle, absolutely, Preeti. Recipients, absolutely, Ahmad. Vehicles, Noor Zulaika says, absolutely. Drivers, Amir Amin, absolutely. Transporter says, oh, yes. Retailers, sellers, police, yeah, wonderful, amazing. Suppliers, retailers, courier services, public services, seller, wonderful. Wonderful. Absolutely. You all are bang on. You all are right. Alongside that, usually what happens is when you meet with accident, what do? You try to call the service center people to come and fix that. And your original equipment manufacturer, that is your truck manufacturers or your vehicle manufacturers, would come and fix this issue. And this is cost. Right, that's called as warranty cost. And if your vehicle is under insurance, what do? Wonderful, wonderful, Noor Idni, you're absolutely right. If your vehicle is under insurance, you claim insurance. So it's an insurance cost. So what we have done is, we have placed industrial IoT sensors on the truck. These industrial IoT sensors are called as TCUs, Telematics Controlling Unit, or ECU, Electronics Controlling Unit. Using that, you transmit the data of various components onto the cloud network, and then you build predictive analytics and descriptive analytics. But we'll first speak about predictive here. In a specific journey, say you're transporting the goods and you're about to start a journey from KL to Johor, you'll predict on whether a vehicle is going to break down or not. Okay, whether the vehicle is going to break down or not. Not just that. Which component is going to fail is also going to be predicted. So whether a vehicle break down or not, will a component fail or not, all these things will be predicted. And after how many kilometers will it break down? If say a specific journey is 800 kilometers, and if the prediction says that your vehicle is going to break down after 1000 kilometers, still you can take a risk and travel. But if the prediction says that your vehicle will break down in the next 200 kilometers, then you don't want to take a risk. These are the kind of innovative data science and AI solutions that you build. In aviation, Korean Airlines is one of our prestigious customers. We do projects for life sciences healthcare in terms of building, cancer prediction models. Let me speak about that briefly. I work as a chief data scientist on a few companies, and there is this Brontobet Analytics. This is a company for which I do consulting, and here you take the radiology images and then you basically build prediction models to predict cancer. This is pathology, right? You have pathology images also. That means your tumor is sent for biopsy. And we built cancer prediction model on that. And that's me, I'm the chief data scientist in the company. Right, so yeah, Ahmed, I would recommend you to read that paper and you'll understand about the heartbeat. Heartbeat is just the signals that you send. In manufacturing, we have Coca-Cola, which is one of our prestigious customers. And Coca-Cola manufactures beverages. We have machines which manufacture. On machines, we have placed IoT sensors such as vibration sensors. If a machine vibrates a lot, it might fail, right? We have also placed sound sensors. So if there's a weird sound coming from machine, the machine might fail. And we have placed blower sensors, chiller sensors, filler sensors, temperature sensors, bunch of sensors. And we started capturing the data from these industrial IoT sensors. Once you capture the data, either you place it on cloud, or if a client says, no, data is very secure, I cannot place it on cloud, then you place it on your own servers. You must be having servers, you place it on your servers. Or there are computers connected to the machines, and that's called a SCADA system, SCADA, SCADA. You store, wherever you store the data, you take that data and ultimately you build ML algorithm on that. What does your ML algorithm do? It will predict on whether your machine will fail or not fail. And this information goes as SMS. These alerts go as SMS to technicians. And what do these technicians do? If there is a prediction which says that your machine might fail in the next 6 hours, your machine might fail in the next 2 days. Based on that, technicians will go and fix the issue proactively. We have done projects in this also. Be it financial services, insurance, energy and resources, retail, social media, analytics, telecom and technology. We operate in all these things. If you have questions on, hey, do all the companies operate across these industries? Absolutely, my dear friends. You take example of IBM. Yeah. So what happens with IBM is they have a lot of industries, if you look at this. And IBM operates in all these industries: aerospace and defense, automotive, banking and financial markets, education, electronics, you name it. Or I'm sure you all are aware of Accenture. Accenture also operates in the space of various industries, not just in one industry, but across the various industries. Why am I showing you this? Because no matter which educational background you are from, you might be from mechanical background, or you might be from computer science background, or you might be from information technology background, or you might be from banking background or finance. Whatever be your background, it does not matter. And you know what? People who usually get trained through us, they are from wide variety of backgrounds. A few of them are from biotechnology background, right? A few of them are from auditing background, internal auditors. They come from wide variety of background, and they are also from something called as education background. There is a company, there are a lot of companies, and Infosys is one such company, wherein they also hire people who are from education background. Okay, logistics, supply chain, oil and gas, you name it, friends, you name it. So and they hire data scientists in all these industries. That means data science is, once again, to repeat, industry agnostic. It is not confined to any specific industry, and also Data science is education agnostic. Whether you have done your master's in biotechnology or master's in seismology, master's in life sciences, healthcare, dental, whether you have worked with a bank or whether you have worked with a logistics firm or a manufacturing firm, doesn't matter. Data science can be applied. Okay, this is very, very important thing that I wish to always explain to our participants, that don't assume that data science is applicable to a specific industry or sector or domain. Okay, then there is another thing that I want to talk with you all. This is data science 101. Let me quickly open the mind map and tell you on how we have structured this program for you guys, just to ensure that we give you the best. Let me zoom it. So this program we are conducting in collaboration with MDEC and 360DigiTMG. We are extremely proud to bring this free program to you all, which is going to cover data science 101, meaning what happens basically in data science, etc. All these things. Then we are going to discuss about basic statistics. Here, we are going to start right from scratch. I'm not going to rush through anything. And we are not going to assume that people attending have some background of statistics, right? We assume that people are very new. Applications of data science, which we are anyways doing. And I'll speak about a few other applications as and how we proceed further. And there is huge amount of time usually people spend on data cleansing. We'll discuss about that. Descriptive Analytics and Predictive Analytics. This is how we are going to, or these are the topics which we are going to learn. It could be up and down here and there, but this is how it will be. And we will also give you a special provision. If you are interested, we will give you a special provision of giving you IBM videos, and you can also avail IBM certificate. Okay. All right. Let's move on now. So we have a lot of domain analytics trainings, marketing, HR, finance, cyber security, internal auditor, supply chain. You might want to go through that. And we have accreditation from TUESUD, German-based certification body, City and Guilds UK, IBM, Panasonic, and bunch of those. Friends, there is data everywhere. Right from your stock market to Internet of Things. And, analytics on videos. When you go to Aeon, right, or when you go to Tesco, or when you go to IKEA, you purchase. When you purchase, there is data which is getting generated. When you purchase things on Lazada, etc., data, or Shopify, etc., data is getting generated. When you use Facebook or LinkedIn or Google, data is getting generated. When you use your smart devices, data is getting generated, and COVID-19 has fast-tracked the number of pharmaceutical clinical trials. Data is getting generated. Even the things which are extraterrestrial, meaning things which are not on the planet Earth, are also generating data. Like you have Mars rover, this also generates data. So there is data everywhere. Do you know how much data is getting generated? Every minute, these many users watch video. 38 million users, right? 4.1 million tweets every minute. 4,000 items are sold every minute. 12.9 million messages on WhatsApp. 1.66 billion people log into Facebook daily. 3.5 billion searches. okay, hiding the information behind the images, right? So on and so. Alibaba, they celebrate a day called as Singles Day. Singles Day means people who are not married, they celebrate a day, saying that we are the happiest people on the planet. Sure, you are, right? On that single day, they make sales worth $38.4 billion. They made sales worth $38.4 billion. Wow, amazing. And why? Why are companies going and running behind data? Because devices are shrinking, right? Devices are becoming smaller and smaller, more capacity, and data centers are getting replaced by quantum computers. And computing, the speed at which the computing or the speed at which people are computing is increasing 300,000 times, friends. 300,000 times every 3.4 months. That means computers are becoming faster and faster and faster. And the amount of data that is getting stored on hard disk is just getting doubled every year. Your network bandwidth, your optical fiber capacity, data that can be transmitted over your network is doubling every 9 months. So on and so forth. Okay. Now, okay, I will ask quickly one question just to understand whether you are able to grasp this or not. I have a poll question for you. Let me see how many of you all will answer it correctly until the end. Okay, and we will give you all a surprise gift if you are responding continuously, if someone is responding correctly throughout. So the question here is data science specific any industry? Yes or a no? Please, can you take this poll question? Yeah, please, can you answer? Data science is 90%, 92% of you all are responding correctly. Okay. If you both go to poll questions, you'll see that. Okay, but then the answer is no. Data science is not specific to any industry. Okay, it can be generically applied to all the industries. Good, friends, good. Another very common question which people keep asking me is, hey, what is the difference between artificial intelligence, data science, data mining, machine learning, and deep learning? What are the difference? Yeah, you're right, Tan. Tan is right. Okay. Artificial intelligence is all about replacing human intelligence using computers. You replace the human intelligence using your computers. Okay. Now let me ask you this. If you have a car and if you're driving, what are the various things that you look into? One is steering. You control the steering, wheel steering. You change the gears. Okay, you apply brakes and you apply brakes and many things. And if all of these things can be automatically controlled by a computer or a robot, that is called as artificial intelligence, and those cars are called as driverless cars, autonomous cars. Okay, that is artificial intelligence. Replacing human intelligence artificially is called as artificial intelligence. And to come up with AI applications, you have data science, data mining, machine learning, and deep learning, and bunch of those. Data science is all about application of statistical analysis, forecasting, data visualization, and bunch of those. All these techniques. Within data science, you have something called as data mining. Data mining has two things. One is supervised learning. Another thing is unsupervised learning. Okay, data mining has supervised learning and unsupervised learning. Okay, and supervised learning is also called as predictive modeling. And within data mining, you have machine learning. Okay, data mining is like coal mining, friends. You have coal, and what do? You dig coal, and you get coal from the coal mine. On similar lines, when you dig into data, you get insights. When you do coal mining, you get coal. When you dig data, you get insights. These insights are meaningful for your management to take management decisions. And machine learning usually is associated with predictive modeling. Of course, there are unsupervised techniques also, but it's usually associated with predictive modeling. That means if there is a person who applies for a loan, can I upfront predict on whether a person will default on the loan or not? Can we upfront do that? Can we upfront do that prediction? Absolutely, you can do that. And within machine learning, you have something called as deep learning. Deep learning is synonymous to something called as neural networks. Neural network techniques are applied, and usually deep learning techniques are applied when you deal with videos, images, audio file, or textual data. No matter what you use, you ultimately end up building AI applications. Okay, and I also need to talk about one more concept which people usually ask, and that is, what is the difference between descriptive analytics okay, or let me do one thing. Let me quickly open our learning management system, and then I'll go to a specific module and quickly explain this. This is our learning management system in which our students, etc. Can you skip one of those onion peels? Sure, you can. It's not mandatory that you need to use all of those, Kushani. You need not, always use all of those. Right? Depending on the business problem, you use whatever is valid. But at the end of the day, you build an AI application that is taken. Okay. These are the various stages of analytics, friends. Number one, descriptive analytics. That's the first thing that you do when data is given to you. Here, you answer questions such as, what happened in the past? If you take all the COVID-19 cases until now, and if you start answering the questions such as, how many COVID-19 cases did we get until today? Right, and in which country, how many cases do you have, etc. That's descriptive analytics. You always speak about what has happened in the past and what is happening now, present, using descriptive analytics. If you ask why, meaning, why are we, yeah, sure, Chung, you'll know that, you'll learn about that. Okay, so saying you have sent a message in probably some other language, Chinese language maybe, we do not understand that. Okay, So that's descriptive analytics. And if you ask a question on why are the number of COVID-19 cases on the rise? Why are the number of COVID-19 cases increasing? That is part of diagnostic analytics. And these two are based on past and present data. And the analysis that you do, especially descriptive analytics part, is called as business intelligence. And for business intelligence, usually you use tools such as Tableau, Power BI, Click, and there are a bunch of tools which exist. Okay, next. So this is all about past, descriptive and diagnostic. Then you have predictive analytics. Predictive analytics is all about future. That means if you want to use the data of the past, and then if you want to predict on how many new COVID-19 cases will come. If Malaysian government says that, hey, I want to know how many COVID-19 cases would you see in the future? Okay, then that's predictive analytics. And finally, you have prescriptive analytics. Let me give you an example. Say there is a machine, okay, and you have sensors, and then you predicted that this machine might fail. Okay, this machine might fail in the next, 5 hours. If this machine is going to fail in the next 5 hours, maybe automatically the machine has to shut down. Right? Automatically you want to shut down the machine. That is called as prescriptive analytics, meaning you take an action based on your predictions. That's called as predictive analytics. And these two are always in the future. The job that is done here and here, descriptive and diagnostic analytics, is the job which is done by a data analyst. Okay, I think there are certain questions coming up. Let me put a poll question here on let me open a new poll. Are you able to hear me fine? Yes or a no? Please can you respond? Okay. So I request everyone to please respond. Yeah, 90% of y'all are saying yes, you're able to hear. 94% rather. So that's fine. So end this poll. I can, in that case, continue. So where am I? I'm here. Okay. So you have data analyst. Data analyst job is to do this business intelligence work. And if you perform predictive analytics and prescriptive, along with diagnostic and descriptive, all of these four, then you will be called as a data scientist. And usually for predictive analytics, we use tools such as R, Python, etc. Yeah, this is what we use. Detecting autism is predictive analytics. What is the action that you take after that is called as prescriptive analytics. Right, Annie? Very early in a kid's life, if you predict on whether that person is going to have cancer, okay, then it's predictive analytics. What action should you take after that is prescriptive analytics. Why is a kid having autism is diagnostic. Hope that's making sense, Annie, Hayati. All right. So these are the stages of analytics which exist. In this, we'll be briefly touching upon descriptive analytics, and also we'll be touching about predictive analytics. Okay. Next, let's move on. Yeah, salaries here of data scientists. Do you know what? Data scientists are considered to be the most expensive today on the planet. Their salaries just are skyrocketing. Okay, and even if you look at LinkedIn analysis, you'll be given the same message. And of course, this is going to be the sexiest job of 21st century. No doubt about that. These are the various things that you need to learn to become a successful data scientist. That's statistical analysis, data mining, supervised machine learning, unsupervised learning, text mining, natural language processing, forecasting, and bunch of things. Learn these, you become a successful data scientist. These are the various awards and accolades that we have. All this is fine. These are the various colleges, companies for whom we have delivered the trainings until now as part of 360, and we have all of those trainers. All right. So this is the first thing that we wanted to discuss. And now we will get into basic statistics by understanding the project management methodology. All right. Let me ask another poll question because, I want you all to understand as much as possible. So here is a question. Shall we take a 5 minutes break and then continue, or shall I continue? Okay, here's a poll. Let me see. I'll go with the poll question first. Okay. 65% of y'all are saying, let's take a quick break and then continue. So I'm left with no other option than to go with the majority. Okay, so let's take a break and then we'll continue. Yeah? What's the time now? It's approximately 3:08, right? So we will connect back at 3:15 p.m. Malaysia time and continue. Take a break and come back, friends. Okay, I think we should get started now. So, okay, I will get to the slides. Okay, and I'm going to explain you the concepts. But even before I get to the slides, I want to walk you guys through high-level overview of a specific project management methodology called as CRISP-DM. CRISP-DM stands for Cross-Industry Standard Process for Data Mining, wherein you understand the business problem, you understand the data, you prepare the data, you perform data modeling, you evaluate the model and deploy the model. All these 6 stages we are going to understand now by going to a mind map. So if you go to 360DigiTMG, in this you will see something called as mind map. You just need to click on that. And here is the mind map certification program in data science. You click on that. Even before you get started on any project, you need to understand the project management methodology which is applied in handling these projects. 90% of the data scientists who just get trained from colleges or universities, they assume that magically data will come and sit on the computer and they have to just work on that data, which is a wrong assumption. You need to understand, where does the data come from? How do you establish the connections among the various disparate data sources? All these things you should understand. Okay, so this, probably for the entire day today, you'll understand that entire picture. Okay, so let's proceed further. CRISP-DM stands for Cross-Industry Standard Process for Data Mining. And if you want to access this mind map, once again, let me tell you that all you need to do is go to 360DigiTMG, and here you see mind map. You need to click on this mind map, and you just need to again click on that, and you'll be able to see that. You just need to double click to expand and double click to collapse. So that's the same thing which is here. First step of CRISP-DM is to understand the business problem. And I'm going to give you a couple of examples here to understand the business problem. So I would go here, I would say CRISP-DM, and I would say we need to first understand CRISP-DM stage 1, which is understanding business problem. Yeah, Tan, KDD is also another, project management methodology which exists, but the most widely used and most preferred is CRISP-DM. If, in the interest of time, if you're interested to know about that, you just need to go to playlist, and let me direct you to the playlist which will help you. Once again, I think that's a private channel that we have created. Anyways. So I'll route you to that video, and you might want to watch that, and you'll understand the difference between KDD, CRISP-DM. Okay. Now let's move on here. Say there is a specific person from a bank. If that person from a bank walks up to you, head of loan department, walks up to you and says that, you know what, significant proportion of customers are defaulting on loan. What does that mean? They're taking loan from the bank, but they're not repaying the loan. If you do not repay the loan, then who are the various people who are negatively impacted? There'll be a bunch of people, bank especially, right? The moment you understand a business problem, there are two things that you need to do. Number one, you have to record business objectives. And number two, you need to record business constraints. You need to record business objectives and business constraints. Here, the objective is very clearly minimize the loan defaulters. What is a business problem? Significant proportion of customers are defaulting on the loan. If significant proportion of customers are defaulting, then what is your objective? Your objective is to minimize the defaulters. How do you minimize the defaulters? Let me tell you. Say you have data, historical data, past data with the bank in the bank database. Bank database will have data on who are the various customers who have applied for the loan in the past, what was the loan amount, what was the interest amount, what was the purpose for which they have applied for the loan, their age, their education, so on and so forth. So you have all the details. And you also have the details on, did people default on the loan or not? If they default, you put default. If they have repaid the entire loan, not default. You have those details and loan amount, interest amount, loan category, age, etc. All of these. Once you have this historical data with you, you take that historical data and you build a machine learning algorithm on that. Okay, you build a machine learning algorithm. And this machine learning algorithm will help you classify on whether people will default on the loan or not default. Okay, if there is a customer who applies for a loan, you have all the details. How much is the loan amount? What is the loan interest amount? What is the loan category, age of the person, education, income, all these details. Given all these details, which are called as inputs, you need to predict whether a person will default or not. Predicting whether a person will default or not is your output. And say your prediction says that there is 90% chance or probability that a person will default. Okay, there's 90% chance that a person will default. Given this prediction, what will you do? Would you approve the loan or reject the loan? What would you do, friends? Would you approve the loan or reject the loan? Yeah, please can you respond? I request everyone to participate. This is in your own best interest, okay? Please, can you all respond? What would you do? If a person has applied for a loan, and if your prediction model says that there is 90% chance that a person will default, what will you do? Wonderful. A lot of you all are saying reject. Obviously, you reject because you want to minimize the loan defaulters. If there's 90% chance, then why would you approve, right? Agree? For people who are saying you want to still approve, here is my question. If I come to you and say, can you lend me 10,000 ringgit? And you know that 90% of the times I won't repay. I won't pay you back. Would you give me the loan? Or would you lend me money? Obviously, why would you want to lend me money if there's 90% chance that I'm going to run away with money? I'll not repay you. Common sense. Right? Okay, very good. So in this way, you build a model. But then, tell me, how do you think banks become profitable? By lending loan, By lending loan or loans, what do banks get? Interest amount. Once they get interest amount, what do the banks do? They take that and based on that, they make profits. Here, in the first place, you're not even lending the loan. You're saying, since there's 90% chance that a person will default, reject. If you reject and do not even lend the loan, then what will happen to profits, friends? What will happen to the profits? Yeah, what will happen to the profits? Do you think profits will increase or decrease if you keep rejecting the loans? Roger says profits will drop. Absolutely. Right? A lot of you all are saying profits will shrink. If the profits are going to shrink, because you're not even lending the loan. If you don't lend the loan, you won't get interest amount. If you won't get interest amount, your profits will shrink as a bank. So your leadership team will come to you and put a constraint on you or a limitation on you. And they will say that while you try to minimize the defaulters, can you help me maximize the profits at the same time? Yeah, but there has to be some innovative way to solve, right? As opposed to just rejecting the loan. And that innovative technique is that you will do this prediction, and also you will do something called as survival analytics. You'll do something called as survival analytics. What does survival analytics do? You are going to do a prediction on after how many installments will a person default. If the prediction here says that there is 90% chance that a person will default on the loan, but then the person will default after 28 months. Then what would you do? You might want to still approve the loan, but maybe you'll reduce the loan tenure to 24 months. You know that there is 90% chance that a person will default, but a person will default after 28 months. If a person is going to default after 28 months, then you might want to reduce the loan tenure to only 24 months. So what are you doing? You're approving the loan. At the same time, you're minimizing the risk of defaulters, because after 28 months, this person will default. If I lend for 24 months, I can get back the money. In this way, you have to start thinking innovatively to address the business problems. Are you all clear? So you first understand the business problem, then you record the business objectives and you record the business constraints. Wonderful. So this is step 1 of your crisp deal. Next, once you're clear with this, you need to proceed further to the next step. And the next step is collecting the data. You need to go ahead and collect the data. And as part of data collection, even before you collect the data, you should be aware of data types. Only then you can collect data, otherwise you cannot collect the data. Okay, so let us understand on how to collect the data. First, let us understand the data types. Broadly speaking, There are two data types. What are those? Continuous and discrete. So first, let us understand continuous. Data which can be represented in decimal format. Okay, data which can be represented in decimal format is continuous data. So what data can be represented in decimal format? Let me give you an example of weight. I might say that maybe, Tan weighs 80 kgs. Makes sense, right? If I say Tan weighs 80.132 kgs, still it makes sense. I'm just giving more accurate number here. And if you want to purchase gold, right? If you want to purchase gold, do you know they go to a very granular level of measuring the weight. It'll be like 0.613928 grams. In that way, to a granular level they go and calculate. So here you're representing the data in decimal format. Still it makes sense. Let me ask this question to you all. What is the cost of 1 liter petrol? 1 liter fuel? Yeah, friends, what's the cost of 1 liter fuel in Malaysia? How many ringgit? How many ringgits is cost of 1 liter petrol? I'm just waiting. I think there is a small lag in getting the Vigneshwari responded as 1.3. 1.3. Okay, you all are giving me in decimals, like 1.67, 1.38. That means it is represented in decimal format. If something is represented in decimal format, what is that called as? What data? Continuous data. Okay, anything that can be represented in decimal format would be called as continuous data. Then what is discrete data? Something which cannot be represented in decimal format. Okay. If I ask you, for example, on how many mobile phones do you have? You might say I have one phone or I have two phones. Would you ever say that you have 1.38 phones? Can I make this statement, friends? That I have 1.38 phones with me? What do you think? What do you think? Can I represent, or can I say I have 1.38 mobile phones? No, that means I cannot represent in decimal format. If I cannot represent something in decimal format, it would be called as discrete data. Like for example, if you ask me, how many people are attending this session? Obviously, I would say there are 270 people attending. Can I say there are 270.16 people attending? You'll be like, oh my God, this guy is mad, right? So you cannot represent something in decimal format. Okay. Now I will ask a few questions and I expect you all to quickly keep responding. The question here is, number of monkeys in zoo. What is this, friends? I asked a poll question. Can you all please respond? Number of monkeys in a zoo. You can have 1 monkey, 2 monkeys, 3 monkeys, 4 monkeys, etc. Can you ever have 1.56 monkeys? No. So it is what data? Discrete data. Next question. Number of liters of petrol. Continuous or discrete? Yep. No, you have to click on poll, Ahmed. There is something called as poll. You need to click on that and answer. Continuous data, exactly. You might say that, okay, here are 50 ringgit. Okay, you fill the fuel for 50 ringgit. In 50 ringgit, you might get probably maybe 35 point something. Okay, or maybe you will get 35.68 liters. So it can be represented in decimal format. If something can be represented in decimal format, it is called as continuous data. Okay, another question. For this, I think I'll explain one more thing and then I'll ask. Okay. Now, within discrete data, you have something called as categorical data and count data. Categorical data means, say for example, will a person default on loan or not? Or not default? You have two categories here. Yeah, everything that can be represented in decimal format is continuous. Exactly, Aswarni, you're right. Will an employee treat or not? Will an employee resign or not? Treat or not treat? Is a patient going to be tested positive or negative? Will a customer churn or not? Will a person claim insurance policy or not? All these are examples of categorical data. If a person gets down at KLIA, right, KL International Airport, would that person take a cab, that is Grab maybe? Will that person take a bus, or will that person travel by train? Different categories. Okay, you can have more than two categories also. You can have either two categories or you can have more than two categories. Doesn't matter. Okay, right, Musa? Will a person pay on time the money that he has taken, or will a person pay ahead of time, or will a person pay with a delay? All these are, once again, examples of categorical data. Yeah, that is also continuous. This one, shoe size, etc., is also continuous. Yes, because measurement, right? It's a measurement on a scale. Right? Measurement on a scale always will be continuous. If you keep your feet here, it might turn out to be 37 point whatever be. So it is called as continuous data. Okay. And then you have count data. Count data means number of flights which take off from morning 9 a.m. to probably 11 a.m. Number of people who visit the shopping mall. Number of people who clear the security check. Number of vehicles which cross a traffic signal. All these are examples of count data. So, question to go. Okay. What is this? Please, can you all respond? Poll question. You'll have to respond. Sorry about that. It is absolutely continuous data. What about this? Categorical, absolutely, friends. Wonderful. Good. How about this? Right? Absolutely. Yeah, then how many times your friend shouts at you or your boss shouts at you? Okay. So you are you guys are now clear with the data types. Okay. Next. Among these, which of these are called as qualitative data and which of these are called as quantitative data? This is also yet another thing that we need to understand. Quantitative means numerical data, when you have numbers. It is called as quantitative data. Okay. Now, out of continuous, categorical, and count, which of these three are quantitative? Yeah. Which of those three is quantitative, friends? Numbers, numerical. And which of these three, continuous, categorical, and count, is qualitative? Exactly, Muhammad Ahsan, and a lot of you are getting it right. Exactly. So your continuous and count data are quantitative in nature. Continuous means it should be numbers only then you can represent in decimal format. And count is also numbers. Okay. Qualitative is categorical data. How happy are you about your married life? For people who are married, you would say, hey, I'm very, very happy with my married life. That is being qualitative. That's a qualitative statement that you're making. But when I say, okay, on a scale of 1 to 5, 5 being very happy and 1 being very unhappy. If you are asked to rate on a scale of 1 to 5, that would become quantitative. Qualitatively, you're saying that you're happy about your married life. That's qualitative. Quantitative means on a scale of 1 to 5, you give a rating. For example, you might say 2. Though you're saying happy here, the moment a scale is brought into picture, you say 2. This is quantitative. So tell me, which would give you more information? Qualitative or quantitative? What will give you more information? Not too shiny. Categorical is not quantitative. Exactly, Hassan. So exactly. So your quantitative data would give you more information always. Always, any day. Your quantitative data would give you more information than qualitative data. As opposed to saying that this training is good versus on a scale of 1 to 5, you give a rating on how good it is. This will give you rich information. This will give you more information, right? You say good. How good? I don't know. But on a scale, if you rate, I get more meaningful information. Okay. There's also another thing that you need to remember. That quantitative data gives you more information. All right. Next thing. Why are we understanding all these things? Because the moment you understand the various data types, you will come to know on what data you need to capture. That is the reason why we are spending some time on this. Next. What do you mean by structured data and what do you mean by unstructured data? Of course, I'll not touch upon every nook and corner of this, but at a high level, I'll ensure that I give you all the required information. Yeah. So structured data. Any data which can be represented in a nice tabular format in rows and columns. Okay, any data which can be represented in a nice tabular format in rows and columns is called as structured data. You can still, it is called as categorical. Nagushani says that they say there is a column called as gender. Okay, where we have say male, we have female, we have data industry, gender. Is this categorical or not, friends? Obviously, this is categorical data. Ahmed, I'm not getting into ordinal nominal for now. Confined to this. Likert scale is quantitative, absolutely, not me. Likert scale is quantitative. So here, just because you're encoding this, what do you mean by encoding? You create a dummy variable, encoded data. You might say male is 1, female 0. Just because you're encoding and representing in numbers does not mean this will become some other data. This is still categorical data only, where 1 means male, 0 means female. Just the notation changed. Right? That's how you have to deal with it. But this is still categorical data only. Okay, count means you'll have how many male, how many female. That's count data. Okay, back to our discussion here. So unstructured data is that data which in its raw format cannot be stored in a tabular format. What could those be? Videos, images, audio files, textual data, etc. And when you look at any video, video is nothing but collection of multiple frames of images. Okay, video is collection of multiple frames of images. And that's called as frames per second. If you have multiple frames, and if you have more frames, it will give you high definition video quality. And within this video, you have frames. This is one frame, for example. You take that frame, and this frame is called as an image. Okay, this frame is called as an image. And every frame of image is made up of multiple pixels. These are all pixels. And you know what? Pixel values usually range between 0 to 255. 0 means black. 255 means white color. And of course, unstructured data is that data which cannot be represented in a tabular format in its raw format. However, you can transform your unstructured data to make it structured. How do you do that? You take your image, you break it down into multiple pixels. You take each pixel value, store it in a column. Take each pixel, store it in a column. Take each pixel, store it in a column. Take each pixel, store it in a column. Take each pixel value and store it in a column. Okay. That's called as transforming the unstructured data into structure. You can do that, but in the raw format, you cannot store your unstructured data in tabular format. Okay, next. You'll have big data, not so big data, you'll have cross-sectional data, time series data, longitudinal, balanced, imbalanced, all of these. So let us understand these four also. And then we will move on to primary and secondary, and then we will get to the data descriptive statistics. Slowly and steadily we'll move on step by step. Big data versus non-big data. Any data which has 3 V's, a few books say 4 V's, a few books say 5 V's, a few other books say 6 V's and all that, right? So if you have huge volume of data, huge amount of data, which is getting generated at a rapid pace, at a lightning speed, and if that data is in variety of forms like videos, images, audio, text, etc., and if there is a lot of veracity in the data, meaning uncertainty in the data, if you have these 4 V's, it is called as big data. Okay. Next. You also have something called as cross-sectional data, or time series data, or longitudinal or panel data. Let us understand these data types also. Any data which doesn't have those 4 V's is called as non-big data, right? Simple. Now, let's discuss about cross-sectional, time series, longitudinal. Cross-sectional data means data which has, first thing is multiple columns. 1, 2, 3, 4. In that way, say you have multiple columns in your data set. say Excel file or CSV, anything, right? If you have multiple columns, number one, it's cross-section. And another thing is, say you have an output variable which says people have COVID positive or COVID negative, COVID positive in that way. And say you have age, historical health conditions, how many times they visited the hospital in the past, and all the various inputs. This Y here is called as output, and this output depends on bunch of inputs. So you have outputs and inputs. Now tell me one thing. Does it work this way wherein a specific patient visited the hospital on maybe 20th November at 11 a.m. Hence, he was tested positive. Another patient went to hospital on 22nd November at 1 p.m. Hence, he was tested negative. Does it work that way? Do you think the date and time is important here? What do you think, friends? I'm sure we all are not that superstitious, right? You might be superstitious, but not this superstitious where you rely on date and time. So the data where date and time, and you're not sorting this data in sequence based on date and time, and sequence. If these three are unimportant, then, and if you have multiple columns, then it is called as cross-sectional data. Okay, then it is called as what data? Cross-sectional data. And if you have number of COVID-19 cases in Malaysia, and say you have data from say 1st Jan, 2nd Jan, 3rd Jan, 4th Jan, that way you have the data all the way until 1st December. Here, if someone cast and tell me how many COVID-19 cases will we have in Malaysia for the next 1 month, can you do that? Sure, you can. But then for that, you need the previous data, which is sorted based on date and time. That means if date and time and the sequence in which you have the data becomes important, right? This data would be called as time series data. And you'll have a single variable. Usually you'll have a single variable when it comes to time series data. Combination of these two, right? Properties of cross-sectional and time series data. If you have combination of these two, it is called as longitudinal or panel data. For example, cross-sectional data, one of the properties is multiple columns. Say you have number of COVID-19 cases for Malaysia. You have number of COVID-19 cases in India, number of COVID-19 cases in USA, number of COVID-19 cases in Indonesia. In that way, say you have data for multiple countries. If you have multiple columns, then you're bringing in the property of cross-sectional data. And since it is number of COVID-19 cases, and if you're representing the data based on date and time, and if you're putting the data in that sequence, this is called as time series data. If you're sorting it based on date and time. If you have combination of these two, it is called as what data? Longitudinal data or panel data. Okay, question coming your way. Let's see who is going to answer this. So the question is, stock market data of which company should I take? Can someone name me a company in Malaysia which is trading on the stock? Say Lazada. I'm not sure whether Lazada stocks here or not. Is this cross-sectional data, or is this time series data, or is this longitudinal? Please, can you respond to that? Okay, DG Petronas. Okay. Stock market data of only Lazada is time series data. Exactly. You're taking a single column called Lazada and you're going to sort the stock market returns day on day, every day. Yeah, wonderful. Another question. Stock market data of India. Top Glove is becoming famous thanks to COVID, right? And here is this cross-section, or is this time series, or is this longitudinal? Yep, please can you respond to this? Longitudinal data. Roger, cross-sectional data is that data which has multiple columns and you need not have the data based on date and time. Okay, absolutely. It is longitudinal, my dear friends, because you're having the stock market data for all the various companies. And whenever it is stock market data, you should arrange that in time series format. Okay, good. You all are with me until now. So there are a couple of other things that we need to talk. Once we discuss about these two, then we will take a break. Certainly breaks are important because it's a 4-hour session and we don't want you all to sleep. It's a dry subject, I understand, but we cannot afford to sleep. So we will, be taking frequent breaks. So you have balanced and imbalanced data sets. What do you mean by this? Let us understand. Okay. Say you have data of an insurance company. And what is important for insurance company is whether you're claiming insurance or not. Whether you're claiming or not claiming. Did you claim it or not claim? In that way, say you have data. And you have various inputs, such as what is the insurance policy about? Is it vehicle insurance or personal insurance, so on and so forth. And say you have data of 10,000 customers. Why are you feeling stressed? Okay, so anyways, let's discuss this. So you have two things. Whether you have claimed insurance, when you take insurance, either you claim it or you do not claim it. Did you claim insurance or did you not claim? Okay, well, did you claim insurance or did you not claim insurance? And say out of 10,000, you have 50%, that is 5,000 of entries which say claim. You have say another 50% which says person should not claim insurance. Okay. So you have 5,000 here and another 5,000 here. Is this called as balanced or imbalanced? Is this called as balanced or imbalanced, friends? If you have 50% of one class, another 50% of another class, it is called as balanced data, obviously, right? If I say 40% and 60%, still it is called as balanced, my dear friends. 30% and 70%, still it is called as balanced. Until when? Until this point. That means if one of these classes is going to be less than 30%, if one of these classes is going to be less than 30%, then it is called as imbalanced data set. For example, if you have 29% here and 71% here, then it is called as imbalanced data set. Or you might have 80% here and 20% here. Still it is called as what? Imbalanced. So either the data can be balanced or the data might be imbalanced. Okay, either you have balanced data set or imbalanced data set. So the thumb rule here is this. When I say thumb rule, people came up with this rule based on some experiments. It's not statistically proven, but you can take it with a pinch of salt. A few books say 20%, a few books say 10%, etc. But majority of the books say 30%. Yes, Musa, absolutely. If one of these classes, either claim or not claim, one of these classes, if it's less than 30%, then you say that the underlying data is imbalanced. But why do you even need to worry about this, right? If you have that question, then let me tell you that when you have balanced data set, you do a different kind of sampling, and when you have imbalanced data set, you apply different kind of sampling. Okay, you can just expand this and you'll get a bunch of those. Finally, we will understand about offline batch data, batch processing, or online live streaming. Post this, we'll take a break. Yes, exactly, Tan. If one of the classes is less than 30%, you say that the data set is imbalanced. Okay, let's move on to the next thing. Live batch data or offline batch data or live streaming data. To explain this, I need a clean screen out here. Okay. Not discrepancy as such, Salasia. That is how the data is. That is how the data will look like. And majority of the data on the planet would be imbalanced. So if you take example of loan defaulters, did a person default on the loan or did not default, did not default, did not default, default. In that way, if you have this data, and if this is your output, take any bank for that case. Do you think majority of the customers default on the loan? Or do they repay the loan? Do they repay the loan or do they default on the loan? Say you have 10,000. How would this be? Only less number of people default, right? Not everyone defaults. It's basically maybe 10% of people default and majority of the people do not default. Agree? This is how it would be. So this is how the underlying data is. In majority of the cases, this is how it would be. If you look at credit card fraud, is a credit card transaction fraud or not fraud? Obviously, very less number of credit card transactions will be fraud. Majority of them will not be fraud. So ultimately, you know what happens when you start dealing with the data in the real world? Majorly, the data would be imbalanced. The nature of the data in itself would be like that. Okay, let's move on now. So I'm going to first explain you about offline analysis of the data, or let me do this. Should we take a break and continue, or should I explain this and give you guys a break? Paul, my dear friend Paul will come into picture because we believe in democracy. Democratically, we will take a decision. So we, or I would say, when should we take a break? Now, after the last topic. Yep, please can you answer? Majority of you are saying after the last topic. So people who want to take a break immediately, you cannot curse me now because I'm going with majority. Okay. All right. Can we, Suhaili, you cannot make an imbalanced data set balanced. You can't do that. But you can handle imbalanced data set using different techniques. All right, let's proceed further with this discussion. Wherein, say this is a database of a bank, and you have data of all the people who have applied for the loan and did they repay the loan or not. So you have an output variable wherein you have details on whether people paid, defaulted or did not default, etc. You have their age, gender, income, education, how much is the loan amount, what is the interest amount, etc., etc. Once you have this historical data, you take that data and build your machine learning algorithm on that. And when you want to build your machine learning algorithm, you can use R, or you might want to use Python. Okay, and you basically use that and predict on whether a person will default on the loan or not default on the loan. Okay, will a person default or not default? And you give a number saying that there is 90% probability that a person will default. Say there is a new person who has applied for the loan. If the prediction says that there is 90% chance that person A will default, you take this number and you write it back to your database. You create another column and you say that person A, there's 90% chance of defaulting. Then maybe for person B, say there is another person B who has applied for the loan. You take all the details such as age, gender, income, educational qualification, loan amount, loan category, etc., etc., and then you build a prediction model. Here, say the results come out to be in this way that there is 10% probability that this person B will default. And say another person, person C, has applied for the loan. What happens? You take all the details, age, gender, income, education, loan amount, interest amount, category, etc., and then you do a prediction. Say the prediction turns out to be that there is 50% probability that person C will default. You take all these details and write it back to your database. And this data, you display it on the dashboard. Whose dashboard? Loan officer's dashboard. There will be loan officer. On the loan officer's dashboard, you display the results. And the results might look in this way. Person A, B, C who have applied for the loan. There is 90% probability that a person will default. What would you do? You'll reject the loan immediately. There is 10% probability that a person might default. What would you do? You'll approve the loan. 50% probability, I don't know. Maybe you'll do further analysis, further checks. And then decide on whether you need to approve or reject. Here, as and how a person applies for the loan, immediately you need not do any prediction. You might put a condition saying that, you know what, I'll take all the loan applications. Daily once, I will take the batch of all the loan applications, and this entire batch of loan applications, we are going to process once in a day, or twice in a day, or twice in a day. As and how people apply, you're not applying a machine learning algorithm on that. Instead, what are you doing? As and how people apply, you take the complete batch of loan applications for the entire day or so, and then you build your machine learning on that. So this is called as batch processing. This is called as batch processing. Yeah, absolutely, Ahmad. You can do that. You can apply your, conventional regression analysis in solving bank loan application. Sure, you can. Absolutely. People do that because regression analysis has some interpretation capability. So they do that. Okay. That's a good question. And that's my answer. Okay. And then I'll give you another scenario of live, predictions. So say you have a database. And here, say you have database of all the credit card transactions which people are performing. And can't ignore it for now. You'll learn that later. So say you have an output variable wherein you have details on whether a credit card transaction is fraud or not fraud. In that way, you have all the details. Then say you have the credit card amount, where did they do the transaction, okay, for how much amount did they do the transaction, so on and so forth. Given these inputs, you also have the output on whether a specific credit card transaction in the past was fraudulent or not. Okay. The moment you have this historical data, you build your machine learning algorithm on that. And your machine learning algorithm will classify whether a credit card transaction is fraud or not fraud. Okay. Whether it is fraud or not, you get to know. And say, prediction says there is 90% probability that this customer A who has done a credit card transaction is fraudulent. What do? You write back those results to your database in a new column and you display the results on a dashboard. On a specific dashboard, you display the results. Okay. And what happens here is customer A, there's 90% chance that this transaction is fraudulent. Immediately your fraud analyst working in the bank would call this customer and ask, hey customer, I got an alert that your credit card transaction, is fraud. Did you actually do that transaction? If the customer says, yes, I've done the transaction, then they'll approve. If the customer says, no, I've not done the transaction, then your fraud analyst will decline the transaction. Making sense? Here, you cannot say that, you know what, I will take batch of all the credit card transactions and once in a day or twice in a day, I will apply algorithm on that. No, it doesn't work that way, right? By then, damage is done. When it comes to credit card transactions, as in how a person does a credit card transaction, immediately you need to predict. So here, we expect real-time processing. Okay. So depending on the business problem that you solve, either it will be a batch processing or real-time processing. Question to you all. Where would I need high powerful computers? Would I need a high powerful computer when I deal batch processing, or do I need high powerful computer when I deal with real-time processing? Where? In what scenario do I need high processing computers? In real-time processing. Wonderful. So you can also suggest your customer, on what should be the speed of the computer, RAM, etc. Depending on the business problem. Only then people will start seeing you as a data scientist. Again, I repeat, data scientist is not a person who will sit and assume that data will magically come and sit on the computer. I just need to work on the data. It doesn't work that way. All right. So, friends, I think it is 4:25 or 4:20 or 4:22. That's the time for that. And let's take a break until 4:35. Okay. And let's come back. Break time. Take a break and come back, friends. Hey, hello everyone. Welcome back to the session. So, we shall discuss more on topics. We started off by understanding about project management methodology called CRISP-DM, and we understood the first step, which is understanding the business problem. Once you understand the business problem, you record your objectives and constraints. Once that is done, you proceed further with data collection. In data collection, we understood about the various data types. And broadly speaking, there are two data sources from which you collect the data. One is primary data source, another is secondary. Okay. Just a moment. Sorry, friends. Just a minute. One second. Extremely sorry about that. Okay. So sorry. Just yeah. Sorry, I could not avoid those responding to certain messages. Sorry. All right. So there are two data sources. One is primary data source and another is secondary data source. Though this says primary and though this says secondary, we always have to go after secondary data sources. Okay, we always need to go ahead with secondary data sources. Secondary data source is data which is collected beforehand. Data which is collected beforehand is secondary data source. And data collected beforehand means data which is already available with a bank. I'll give you an example of a telecom company. Say this telecom company approaches you and says that, do you know what? We want to, revamp our data plans for people who stay in villages, rural regions. Okay, and this telecom company asks you, because you're a data scientist, on what are the various plans that we need to provide to the people who live in villages or rural areas. Okay, for people who live in villages or rural areas, we want to come up with a plan, is what they say. Okay, and you take the data which is already there with the telecom company. Telecom company already has the details about what is the plan, data plan which people have taken. Was that a prepaid connection or a postpaid connection? Right? Was it 1 year plan or 6 months plan, etc.? All those details are already available of the existing customers. So people who have already, people who were already using probably TM services. all their information would be available with you. This data is already available. Data which is already available with you is called as secondary data source. Okay, data which is already available with you is called as secondary data source. But you as a data scientist will not just rely on this. You'd also look at something else. And what is that something else? You maybe want to look at publicly available data, which is open source free of cost, right? But that data is already collected. For example, say Google Maps. Okay. And if I say that there are two villages, village A and village B. Village A, when you look at Google Map, has some water body around it, and village B does not have a water body. Okay, village A has a water body, village B doesn't have a water body. Which village do you think would be more prosperous, village A or B? That village which has continuous water supply, or that village which doesn't have water supply? Which village would be more prosperous in terms of farming or in terms of cultivation, etc.? What do you think, friends? Village A. Exactly. So that means this is giving you more insight, more information. And say there is a specific village wherein all the houses are neatly structured in this way, straight roads, nice buildings, versus there is this village wherein the roads are crooked like this. Which one would be more prosperous? Obviously A. So your Google Maps is giving you a lot of insights, a lot of additional data, which can be clubbed with the data given to you by your customer, and that makes your analysis even better. Google Maps is open source. Openly you'll get the data. But if you want to zoom in to the extent of understanding what crop do they cultivate in that village, to that extent if you need data, then Google Maps won't give you that data. What data, what will give you that kind of granular information? Drone data. You fly drones, and drones will capture images. You take those images or videos and then analyze. But this data, if you zoom, you won't get clarity. Okay, so drone driven images is what you try to get. Okay, and this drone data is usually syndicate data. What do you mean by syndicate? You need to go purchase the data. Someone else would have already captured the data. All you need to do is go pay the money and get the data. So in short, data which is available with the customer, or data which is publicly available open source, or data which is already available but you need to buy that data, these kind of data sources are called as secondary data sources. Is this clear, friends? These kind of data sources is called as secondary data sources. Okay, now if the data that you need is not available in the secondary data source, then you need to proceed further with primary data source. For example, we have done a project for a company in USA which was specialized in educational loan. Okay, educational loan. Here, this specific bank who has approached us to do the project already had the information on who are the students who have taken the loan, what was their age, to which colleges or universities did they apply, what specialization did they choose, and all these details. And did they pay the loan, or did they not pay the loan amount? Did they repay or did they not repay? Such data was there. But this data wasn't sufficient. This is what customer already had, so it was secondary data. We thought we will make this specific data even more comprehensive. And what we have done is we have added a few more columns. What were those columns that we have added? We have added additional data such as number of friends. We've scraped the data from social media. Number of friends that a person has on Facebook. What kind of posts people are doing? Emotions. Is a specific student always posting about negative things? Always posting about, maybe some kind of disharmony in the society? Or is he speaking against political system? What is the student actually, displaying as part of his comments or posts? That data. And then they've also extracted details on, is this person a gadget freak? The moment iPhone 12 is released, this person will be the first person to purchase and post on social media that he purchased a new gadget. That means, given a chance, will this student repay the loan, or would that person prefer purchasing a gadget? And we have also posted details on, does this student always go on international trips or some kind of outings, etc. If a person frequently goes on outing and posts pictures on Facebook, what does that mean? That means that this person is a spendthrift. This person may or may not have the money to repay the loan. So all these kind of insights we could glean by doing what? By extracting the data from social media. And that is primary data source, because you're going and collecting the data now. For your business problem, you are now collecting that data. The data is not already captured and kept handy for you. You're going and scraping the data and getting the data. Right? That's social media extraction. So first, you go after secondary data source. If you do not have the data needed for your analysis, then you go ahead with primary data source. That's data collection. All right. Once you collect the data, you proceed further with data cleansing, data preparation, or exploratory data analysis, or feature engineering. All these are the names which are interchangeably used, or all these are the things that you perform as part of step 3. And trust me when I say this, my dear friends, when you become data scientists or AI experts, approximately 60% to 80% of your time you spend only on these 3 steps. 60 to 80% of your time you spend on these 3 steps, my dear friends. Okay? Only 20% of your time approximately you spend building your algorithm. But when you prepare for your interviews, etc., 80% of the time you spend here and 20% of the time you spend here. Because that's how it is. There are far too many algorithms that exist, so you need to know all of that. However, when you practically work on projects, it's 60 to 80% on these 3 steps and only 20% on your machine learning algorithms. Okay. And a few of the colleges, universities are teaching only this part, machine learning algorithms and all that statistical analysis. But students are not taught on what happens as part of data cleansing and all that, right? Those are also very important, friends. Okay, anyways, let's move on to step 3. And within step 3, there are 1, 2, 3 subdivisions, sub-steps. However, you cannot delineate or segregate these 3 steps from one another. You cannot do that. All these 3 steps would overlap with one another. Hence, we will now understand B. Okay. First, we will understand B, then we will get to A, then we will get to C. That's how we are going to traverse. But before we do this, we need to understand a few things about probability distribution, etc. So here is where I switch to slides. And we will get started with probability. How many of y'all are scared of probability? How many of y'all are like, oh my God, this is back again. I thought in my school days I will get rid of this, but it is haunting me throughout. How many of y'all have this fear factor? I certainly have, so I just want to know how many of y'all have this fear factor. Yeah, friends? How many of y'all have the fear factor? Yeah, it has to get technical, more technical, Tan, because otherwise people won't pay you salaries, right? Huh? A lot of y'all, right? You're responding me slowly, softly, in private also. Yeah, sure, I'll not name you guys. It's only between you and me. Okay? Yes, absolutely. You know, a lot of students, a lot of even professors, lecturers you get in touch with, they say that probability, oh my God, not again. So we will try to demystify this. Do not worry, friends. We will. So we will make it very, very simple, okay? Probability formula. The formula of probability is number of interested events divided by total number of events. Okay? And if you're rolling a die, if you roll a die, what are the various numbers that you get? You can get either 1 or 2 or 3 or 4 or 5 or 6. You can get any of these numbers. So the total number of events are how many? Total number of events are equivalent to 6. You have 6 total number of events. Suppose you roll a single die. What is the probability that the outcome would be? What is the probability that the outcome will be bigger than 3? Bigger than 3. How many numbers do you have bigger than 3 here? 4, 5, 6. So you have 3 numbers. 4, 5, 6. So you have 3 numbers which are bigger than 3. So the number of interested events will be 3 divided by total number of events are 6. So you get 3 by 6 for this. Next. If you roll a die, what is the probability that outcome will be equal to or bigger than 3? Equal to 3 or bigger than 3 would be these numbers. 3, 4, 5, 6. So number of interested events are 4 numbers divided by total number of events are 6. It's 4 by 6. Then smaller than 4. How many numbers do you have which are smaller than 4? 1, 2 and 3. 1, 2, and 3. So you have 3 numbers. Number of interested events are 3 divided by total number of events are 6. So it's 3 by 6. Next. What is the probability, if you roll a die once, what is the probability that you get a number which is greater than 2 and less than 6? Greater than 2 and less than 6 are these 3 numbers, 3, 4, 5. So once again, number of interested events are 3 divided by total number of events are 6. So it's 3 by 6. So the probability that the outcome is greater than 2 less than 6 is 3 by 6. This is all you need to know, my dear friends, to learn probability to get started. If you remember this formula and if you keep applying this formula throughout, you would feel that probability is like a walk in the park. It will be a breeze, absolute breeze. Okay. Now let us understand something else which is called as random variable. If you read this, you'll be like, oh my God, what is this again? Right? For example, a random variable describes the probabilities for an uncertain future numerical outcome of a random process. My head is spinning now, right? So because this is very heavy statement. In order to understand this, we need to basically split this into 2 components. One is called as variable, another is random. If you flip a coin, would we always get a head? Will we always get a head if we flip a coin? Or can we also get a tail? What do you think? We can also get a tail. Okay, you can get a head or you can get a tail. So the output varies. If the output varies, it is called as variable. Variable, it's called as variable. Okay, if I roll a die once, would you always get 1? No. We can either get 2 or 3 or 4 or 5 or 6. That means output varies. If the output varies, it is called as variable. First component. Second, what do you mean by random? Random means if there is a chance or probability associated with each of these events, then it is called as random. Now first let me write down the probability formula once again. It is nothing but number of interested events divided by total number of events. Number of interested events by total number of events is nothing but probability. What is the probability that you get a head when you toss a coin? Probability of getting a head is a single event. So number of interested events are 1 divided by total number of events. How many total number of events do you have? 2. So it's 1 by 2. What is the probability of getting a tail? Tail is a single event. So the number of interested events is single divided by total number of events are 2, head and tail. So you say 1 by 2. So whenever the output varies, it is called as variable, and when you have a chance or probability associated, it is called as random. When you have both these properties, it is called as random variable. What is the probability of getting a 1? One is a single event. So the number of interested events are 1 divided by total number of events. In total, how many do you have? 1, 2, 3, 4, 5, 6, 6. So it's 1 by 6. What is the probability of getting 2 friends? Yeah, who will answer this? What is the probability of getting 2? Yeah, I request you all to please respond. 2 is a single event. So the number of interested events are 1 divided by total number of events are 6. So it will be 1 by 6. For 3 also, probability will be 1 by 6. For 4 also it's 1 by 6. For 5 also it's 1 by 6. And for 6 also it is 1 by 6. Okay, so the moment there is a chance or probability associated with each of the events, it's called as random. If you have both the properties, it's called as what? Random variable. Simple. And random variables are always represented using a capital letter. For example, you have age of people. You represent that using capital letter. It could be capital A, capital B, capital C, capital letter. And age could be 32, 36, 28 in that way. The values here would be represented using small x. Capital X is this. The values which your age can take are represented using small letter, lowercase. Next. Probability values range between 0 to 1. Maximum value would be 1. And another property is, if you add all these events, probabilities of all these events, so head is 1 by 2, tail is 1 by 2. When you add the probabilities of all these events, it will turn out to be 1. So that means 1 by 2 plus 1 by 2 is 1. When you add all of these, 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6 plus this, do you know how much you'll get? 1. So summation of probabilities of all these events, when you add, it gives you 1. What are you doing here? You're taking this probability 1 and you're distributing it across all these events. You're taking a probability as 1 and you're distributing it across the various events. Then it is called as probability distribution, because you're taking a probability and distributing it across the events. Okay, anyways, so the probability is getting distributed. Can someone tell me, what do you think is the mood of your manager? Would that be called as a random variable? Mood of manager. Your manager's mood. What do you think it would be? Can I call it as a random variable? It always varies. And it will have a probability associated with it. Agree, right? You all? One of our friend was saying that I'm not married. Sure. Then what is the mood of your girlfriend? Random. Just ignore me for the examples that I'm giving. These are just some random examples. All right. So mood of your manager would be usually random. Okay. Now let us understand another concept, which is called as probability distribution. Okay. All right. At around 2:45, we'll quickly take just 5 minutes break and then we'll continue. Yeah. Depends whether there are quarrel or not. Okay. Whether there is going to be quarrel or not, is that random variable term? Can I say that? Okay. Anyways, probability distribution. Let us take this example where, say we have daily sales of Apple iPads at a specific store. You have the daily sales of Apple iPad. Okay, then, which is random. And you say you have the data for 1 month, for 30 days, 11, 12, 13, all those days. You have the data of 30 days. If you have 30 days data, and then if you want to calculate any probability, it will be number of interested events by total number of events. And what do you think will be the total number of events if you have in total 30 days data? Total events will be 30. So number of interested events by 30. And say on day 1, you could not sell any iPad. On day 2, you sold 4. On day 3, you sold 2 iPads. On day 4, you sold 3 iPads. Day 5, you sold 1. So you have data in this way. Okay. You represent this data in a tabular format. In this table, what is happening? You have your random variable and you're representing your random variable in this way. So you could sell either 0 iPads or 1 iPad or 2 iPads or 3 iPads or 4 iPads. And you have the corresponding probabilities. How did we calculate this? Let's see. Probability of selling 0 iPads is nothing but number of interested events, which is number of times you have 0. 1, 2, 3, 4, in that way, multiple times. Say you have 12 times or 12 days where you could not sell any iPad. So it's 12 divided by 30. When you solve it, you get 0.4. Okay, then probability of selling 1 iPad, then probability of selling 2 iPads. In that way, you got the data. Say probability of selling 2 means number of times you see 2, 1, 2, 3, 4 in that way. Say on 6 days out of 30 days, you sold 2 television sets. When you solve it, you get 0.2. In that way, for 3 iPads and 4 iPads, you have the data. When you add all these probability values, how much would be the summation equivalent to? Or what do you think should be the summation? Summation should be equivalent to 1. Exactly. Probabilities of all the events, when you add them up, it will turn out to be 1. So what are we doing? We are taking this probability 1 and we are distributing this probability across all the events. When you take your probability and distribute the probabilities across all the events, what is it called as? Probability distribution. Because I'm taking a probability and I'm distributing it across. All with me? You can either from your raw data represent the data in a tabular format, which is called as probability distribution table, or you can represent probability distribution in a graphical format. So you have a probability distribution, graphical representation. So here you have x-axis, which has a random variable. Random variable is nothing but sale of iPads. And on y-axis, you'll have probability values. So you have random variable, which is nothing but sale of iPads. You put 0 iPad, 1, 2, 3, 4, all these 4 here. And for each one of that, you have a probability associated. For 0, you have probability as 0.4. For 1, you have a probability as 0.25. For 2, you have a probability as 0.2. Against 0.2, you plot. For 3, you have a corresponding probability 0.05. So again 0.05, you draw the line. For 4, you have a probability as 0.1. Okay, so this is called as what? Probability distribution. Now, yes, exactly. Exactly. That's a comment that you can make. All right. So let us discuss about inferential statistics. Okay. And before that, we will take quick, just 5 minutes break, and then we will continue. Because after that, anyways, there won't be any break, and then we have to finally end the session. So what's the time now? It is, could be. What's the time there? 5:15 or maybe 5:14. So we shall connect at 5:20. Okay, or let's connect at 5:25. Quick 10 minutes break, and we'll then continue with the remaining session. Please take a break and come back, friends. Okay, let's proceed further. So we shall now discuss about inferential statistics. Let us understand what do we mean by inferential statistics. One thing is we have population, and Malaysia has signed a pact with Pfizer in procuring vaccines. Okay, and do you know how many people are infected with COVID-19 overall? Approximately how many? 64 million, is it? 64 million people are affected by COVID-19 across 218 countries, if I'm not mistaken. Let me open that. Look at meters. Yeah, 63.6 million people, total COVID-19 cases. And COVID impacted 218 countries. So we have 218 countries. And you have 64 million people who are impacted. So you have the population. Population means all these 64 million people who are impacted by COVID-19 would be called as population for this problem that we are solving. For this problem that we are solving. And if you take example of, say, HSBC Bank or maybe Maybank, number of customers. How many customers do we have? Oh, there are 22 million customers for Maybank. So 22 million customers form what? These 22 million customers would be called as population for this bank called Maybank. Okay, this is how you have the data. This is called as population. This population is, I mean, if Pfizer wants to test the vaccine, can it test on all these 64 million people? Can Pfizer test new vaccine on all these 64 million people, friends? What do you think? Is it a possible thing? Not really. Because in order to test vaccine on all 64 million people who are infected with COVID, they would go bankrupt and it will take probably another 10 years to complete. So it's not possible, not practical. Hence what people do is they come up with something called as a sampling frame. They come up with something called as sampling frame. Sampling frame which is something which is crafted based on business knowledge. And it's dependent on business strategies. Maybe senior management at Pfizer might think that, or maybe they thought that, do you know what? If we test on all 64 million people across 218 countries, it will be a Herculean task. So let us do one thing. Let us choose probably the top 20 countries which have highest number of COVID-19 cases, top 20 countries. Out of 218 countries, choose only top 20 countries. So you basically choose top 20 countries and you call this as your sampling free. How did you come up with this? It's a business decision. Based on some senior leadership discussions meetings, you come up with a sampling free. Once you have a sampling free, you apply a technique called as simple random sampling. Simple random sampling. SRS. This simple random sampling technique is a blindfolded technique. That means you just close your eyes. Okay, you just simply close your eyes and randomly pick some people. And that would give rise to a sample. And you take more, probably 10% of the people from these top 20 countries, or 20% or 30%, whatever. More the data, better it is. In the good old days, there were no powerful computers available, so they were very, very careful in selecting the sample size. Today, we have ample amount of compute available, so the more the data, better it is for us, for analysis. So you take a sample, though you work on a sample, you make statements about population. Okay, though you work on a sample, you make statements about population. When you work on a sample, and if the results are that vaccine which Pfizer has come up with is working well on the sample, then what will Pfizer do? They will draw inferences about the complete population. They'll say that, you know what, when you take our vaccine, there is 100% efficacy. Moderna, there is a company, another pharmaceutical company called as Moderna, they're saying, right, that we have 100% efficacy. So what are you doing? You're working on a sample, but making statements about population or drawing inferences about population. Hence, this statistics wherein you work on a sample and make statements about population is called as inferential statistics. Though you work on a sample, you make statements about population. That is called as inferential statistics. Okay. Is this clear, friends, or do you have any doubts? Please confirm. No, Lavanya, to answer your question now. Okay, fine. So let's move on to the next concept. It's a random decision that you take normally. You can choose any percentage. As I've told you, more the data, better it is. In the good old days, they were very particular on how to calculate the sample size. But ideally, the thumb rule is that if you have more than 30 samples, it's good to get started. It won't guarantee good results, but it's at least good to get started with your analysis. At least if you have 30 data points. Okay. So let's understand measures of central tendency. Just give me a minute. So sorry. Okay, so let's understand this. We now understood the business problem, we collected the data. Now we are in stage 3. In stage 3, we will discuss about this, which is called as exploratory data analysis or descriptive statistics, in which we have first moment, second moment, third moment, fourth and fifth moment business decision. In this, let us understand the first thing, which is called as measures of central tendency. Okay, let's understand this one. So when it comes to measures of central tendency, yeah, okay. We have another 15 minutes, it seems, to left, basically. So let me do one thing. Yeah, recording is going on, my dear friends. So I'll do one thing. I'll give you certain context here, okay? Number one, tomorrow we are going to complete this part, which is called as descriptive analytics, 1, 2, and graphical representation. So descriptive analytics or descriptive statistics will be done. And we will then move into some amount of data cleansing, and we will enter into predictive modeling, supervised learning or predictive modeling. We'll discuss about one of the predictive modeling techniques. Okay? And all these three, we shall be doing it on basically one of the statistical programming languages. Okay, and which language is much better, right? Other than R. So we will be making use of a software called as R, and you'll have to download and keep it ready because we will have a hands-on session. What do you mean by hands-on session? So the first thing is you have to go and download R. Keep it handy, download and keep it handy. If you're using Windows machine, you download for Windows. You say download R for Windows. When you click on this, you'll get this. So you have download R for Windows, and you'll download a software, just install it. If you have, if you want to download R for Mac, then say download R for Mac, click on this, and you'll have to click on this and download. Okay, then alongside this, after you download and install, for whatever be the operating system, you'll have to download R Studio. These two are free for individuals like you and me. Okay, so when I click on this, you scroll down, you see this free option, click on that. And you'll be able to download R Studio for Windows or for Macintosh or for Linux variants like Ubuntu, Debian, Red Hat, OpenSUSE, etc. You download either for Windows or Mac or any of these Linux variants. Okay. Download and keep it handy. We will be doing a hands-on tomorrow after learning these concepts, right? We'll be learning all these concepts and we'll be practically doing it in class. We'll do it. Okay, so that's one thing. And there is another benefit that you guys have. Tomorrow there is going to be there's going to be an amazing announcement that we will make. And tomorrow you should not miss out, tomorrow towards the end. And also for this session that we are conducting today and tomorrow, if at all you want, if you want, this is not mandatory, this is optional. If you want IBM certificate, there'll be an exam. Okay, and you'll be notified further tomorrow on how to take the exam, what is the fee going to be if you want to, etc. Okay, and there will be a link which is posted on your chat window. If you can see that, you need to click on that link and give your attendance. So click on the link provided and mark attendance. Okay, please do it without fail because this is mandatory. We need to submit the attendance of 2 days to IBM. Only then they will allow you to take the exam if you want to, if you opt for that. And surprise will be tomorrow. We give back to the society in a big way. So we will announce that tomorrow. So please do not miss the class tomorrow. Having said this, if you have any questions, please ask me now. And if you have no questions, okay, yeah, you can start giving your attendance in another 2 minutes. Even before the session ends, I quickly wanted to notify that. Okay. And in the interim, let me do a quick recap on what we have discussed. We discussed about CRISP DM, which is project management methodology. The first step is understanding the business problem, and then you record the objectives and constraints. The second step is data collection, wherein you need to understand about the data types and the primary and secondary data sources. Then you proceed further with data cleansing. Before that, we understood we understood on what is probability distribution, okay, and what is inferential statistics, wherein you'll have a population, a sampling frame, you apply simple random sampling, and then you get the sample. There will be an exam. This IBM certificate is not given for free. There will be an exam. Okay, and the link that you have for the attendance would be given, would be active in the next 1 minute. And Lavanya, there is a question on would they get certificate of attendance? You might want to just put a message. Yeah, mind mapping file is there, and yes, it's there on our website. All you need to do is go to 360DigiTMG, click on mind map here. Okay, the moment you click on mind map, you see the certificate program. Okay. There is no certificate of attendance, friends. Sorry. Yeah, there will be MCQs, multiple choice questions. Yeah. Narkushaini has given the link. Yeah, MCQs will be MCQs. 70% is the pass mark. You can answer that. I don't know, Jaya Krishnan. So Lavanya, would you mind responding to that? Can they watch the recorded video? You'll be given certain IBM videos, I think. And then tomorrow we will confirm that, Mansur. You'll be given IBM videos also. You will have to watch those videos and then take the exam. One second, let me confirm right away. It's called as Epic Pen. The software is Epic Pen, EPIC. Yeah, please go ahead with your attendance. No, no, exam is not tomorrow. We will be giving you the IBM credentials. IBM videos access will be provided. Watch these and prepare well, and then take the exam. IBM certificate exam cost is 100 ringgits. 2 days attendance is mandatory to apply for IBM certificate. Attendance link is provided on chat window. So please give attendance. Yeah, anything else? Download R and R Studio for tomorrow's hands-on. If not, I will guide you tomorrow on how to download. Yeah, anything else? No. 70% is pass mark and 1 attempt. Until now, 100% participants passed. Okay, don't worry. It won't be very difficult. All right, friends. Thank you so much. Have a good evening, and thank you all. Bye.